You can still see the email, isn't it? Guys?
Yes, sir.
Are you fine, guys? Are you okay?
Yeah, we are fine.
Oh, it's fine. Again, you'll be collecting your script, quiz 2 scripts. Um, Keep on checking the blackboard or the what? Uh, that chat thing that you have with your Atlas rep. We'll communicate with them. You have to collect your scripts today so that you can see your mistakes, what you have done wrong, because you may assume that what you wrote is correct, but when I check, most of you guys, what you wrote is not correct. So I've decided that it will be very, very important maybe for you to get your script so that don't go and repeat the very same mistake in the test tomorrow. So the one of the questions that I received from the leader is some of the emails I'm getting them from at 3 a.m. But it's fine. It shows that you want to pass. Um, she's saying, it's a man. Is saying if we are given two independent variables x1 and x2, then we are asked to find SSR of x1 given x2. The answer will be this is true. I agree. This is true. From what I know, I can compute SSR of x2 using the formula. You are right, leadership. So here's the question. So now, let's say I have four independent variables, bringing x1 to the model given that you are already having x2, x3, x4. Will I still be able to use the formula? No. As I've indicated, for partial F test, I will stick to maximum of two independent variables. Partial F test, partial coefficient of determination, I will stick to only two independent variables. If I want you to solve a question related to partial F test. But to answer the leader, we have another method that will cover hopefully next week, which is where we can test for whatever you're asking, but not using the partial F test. We'll be using this other section called nested models. So next week, I think I'll be able to cover that section. So whatever leadership you're asking, it will be covered by nested models, which the section I'll cover it hopefully next week. Now let me move to another leader. Um, so can you see the one now from Sibula? The email from Sibula? If you have follow-up questions, guys, please ask. If you have follow-up questions, please ask. Say on this attached question paper, question 3, I'm required to interpret the given output information generated from a software. My question is, what are the necessary steps to be followed when answering the questions? This question. How do I answer this question? What must I perform to get all the marks? All these marks. So, you remember at the beginning of the semester, Mr. Chabalala gave you a certain flow chart. A certain flow chart where it's talking about what is the first step that you have to do when dealing with simple linear regression. You indicated that the first part that you do what? You can find the scatter plots, try to interpret the relationship between the two independent variables, try to visualize what is happening from your data set by using what? Scatter plot. Before you can even do any calculations, you just check your scatter plot, try to reason, try to check what are you suspecting before you can even start solving the problem. You know that the next step that you did with Mr. Chabalala, it was to fit the what? The regression model. So even yourself, follow that order. look for the information. You know that when you're given a problem, maybe multiple linear regression problem, you can run scatter plots between y and the what and the independent variables. I didn't check the output, what is how the output looks like, but just to guide you on how can you answer the question, you look at the given output. You know that the first thing that you have to do when you're dealing with given a problem is to draw a scatter plot. Suppose you are not given an output, you are asked to run the results. The first thing that you can do, you can find what? Scatter plots. So check from the output, do I have the scatter plots between y and the independent variables? Y and x1, y and x2, y and x3. If no, move to the second step. What do you do next? You feed the model. Look for the model from the output. Write it down. Interpret the betas. You have started now. Look for the model from the output. The issue is not to follow the order, no. But you can start by saying, if you're given a multiple linear regression problem, you must indicate that I'm given this problem with 4 independent variables. You can even explain. You can have an introduction. Introduce us what you are about to interpret. You can simply say, I'm having a multiple linear regression problem with 3 or 4 independent variables. Indicate to us what type of independent variables are you having. If you're having a variable which is categorical, indicate that I'm having 3 independent variables, but 2 are quantitative. One is qualitative, is categorical. And then you come with the questions. You can even indicate that the sample size for my given problem is this one. You are introducing us to what we are about to interpret. From there, you can also indicate the alpha that we'll be using to what? To remove or to add variables, or the alpha that was used to remove and add the variables. At the beginning, you are just introducing us. From there, you write the model. You look for the model from the given output, you write it, you interpret the betas. Now you can look for another thing. What else can you look? You can check for, test for the overall model. Because you know, before you do go for T, you must start by testing for the overall model. Look for a step which can help you to test for the overall model. From there, if you reject the null hypothesis, is then now you can move to what? You can move to testing for each coefficient. You can use the confidence interval for the betas if they are given, or you can use the t-test, but make sure that you don't go to the table. When you are asked to interpret an output, you don't need any value from the table. You interpret based on the given information. After doing that, now you can check the variation of y that can be explained by what is there. You can also, that can be explained by the other independent variables. Now, after that, what else can you do from that? If you're having residual plots, now you assess the model. You start explaining if some assumptions are not violated, exactly the same way that you have done with Mr. Chabalala. But for the upcoming test, for tomorrow's test, I won't ask you to interpret an output. Remember the questions that I've been bringing from the quizzes. If I bring questions, I'll bring questions related to those ones. I cannot give you that question. I say, interpret the output, and I say 20 marks for tomorrow's test. No. Tomorrow's test is as we have agreed. So don't panic. Say, if I give me this question tomorrow, what will I do? We're still coming to that one. There will be a day where we'll run an output. I'll run an output like what Mr. Chavala did, and then we go step by step just to guide you on what are the important things. Can I continue, or you need more clarity? Should I continue, or you need more clarity? Mr. Sibula, are you here? Guys, are you here?
Yes.
So continue.
Okay. So if you send me an email, Please, now I'm going to Connie. Connie is good morning, good afternoon, sir. When we sum up the age, are we going to write 1 or 0 where the vehicle is 1 year old? No, 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 no. You capture that 0. Remember, here I was trying to indicate that whenever you replace 0, you're simply saying what? This car is what? Is less than a year old. But whenever you write that 0. It means there you want to take the car for maintenance, but uh, it's for less than a year. Maybe you took a car for maintenance while you are having 10 months. We cannot record 10 months there, because if we record 10 months, it means you'll confuse it with what? 10 years. So whenever we cannot capture 10 months. So whenever you see a 0, it's the person took the car for maintenance, which was having less than a year old, which was less than a year old. So whenever you want to do some calculations, you use the 0 the way it is. Can I continue? That was the only question from Connie. Yes, that was the only question from Connie. Mangani, sir, are you available at the office today? Yes, I'll be available. Remember, even now I'm teaching from the office. So I'm here. I indicated from Blackboard that I don't accept consultations on the day of the test, but today I will accept that. So I'm here, Mangani. If you want to consult, feel free. Even though I'll be having a meeting from 9 to 1, but you can come, it's fine because it's visual. Refilwe, if you send me an email and I missed it, please let me know. Good morning, sir. I have this. She wants assistance with chapter 5, forward elimination. So I understood the first part where we select the first variable that becomes part of the model, because it's the variable that is highly correlated with the dependent variable. I do not understand how we make decisions to add the other independent variable after finding its partial f given with the given model. So my other question is about variance covariance matrix. So I understand the part where you said we take the diagonal values as our variances for beta 0 until Bn, depending on the number of our independent variables. But I'm confused with the matrix we used to find it. Let me answer the first one. I said when you use forward elimination method, the first variable to be entered is based on how it's related with y. You can find the correlation coefficient between y x1, y x2. If you are having 10 independent variables until y and x10, you check the one that is highly correlated with y. You enter that variable first. The second variable to be entered, I said it will be based on partial coefficient correlation or partial coefficient of determination, or you can check. I said it in one of my classes that, or you can check the MSE from each and every, let's say you are given the ANOVA tables, you can even compare which variable to be entered first based on what? On their MSE. The variance with the lowest MSE, it means that variable will be entered first. But now to stick to the leader's question is that you find partial coefficient of determination. How do you do that? Or correlation? You say r squared of y. Remember, I'm saying suppose you are given 10 independent variables, and the first variable that was entered, let's say, is x10. So it means to know which other variable to be entered, you will find partial coefficient of determination of x1 given x10. Remember, x10 is entered from the first step. Now you check, you write its value. Now again, you calculate r squared of x2 given x10. You find the value, x3 given x10, you find the value up to the end. Now you check which one is having the highest value. The one which is having the highest value will follow what? Will follow x10. Suppose the one which followed was x5. Now to bring in the third one, you will use what? Now you'll find partial coefficient again, coefficient of determination by doing what? R squared of x1 given, remember I said x5 and x10, now they're entered. X1 given x5 and x10 are already in the model. You find the value, you calculate again r squared of x2 given x5 and x10 are already in the model. Like that, you do the comparison. And from there, you check which one is having the highest. You enter it in the model. Did I answer your first question, Refilwe? If she's here, maybe I must first check if these people are here before I can even answer their questions. Because if they're not here, so then why? Refilwe, are you here? Moving to the second one. So I understand where you said we take the diagonal values as our variance for B0 until Bn, depending on the number of our independent variables. But I'm confused with which matrix we use to find it. You first multiply the MSE with your inverse. You multiply everything, but if you are asked to test using the t-test, or if you are asked to find the confidence intervals, the only values that you need is the diagonal values. So to respond to leadership, to reply to leadership as question, you will say what? MSE. I'm answering the second question. In an MSE multiply by the inverse. I'm answering a question like that. MSE multiplied by the inverse is the matrix that we'll be using. After multiplying the two, you focus on the diagonal line, you'll find your variances. Remember, those ones are not the standard deviations, it's your variances. Do anyone who's having a follow-up question from Refile? Anyone having a follow-up question from Refile? It seems like
Morning, sir.
yes.
Yes, sir. I heard you. I'm having network problems, but thank you.
You understand what? Did you understand? Refile? But you can, if you are around, guys, feel free to come and consult. If you are not following, feel free to come and consult.
Sir,
We want to help you guys. Yes, leadership.
so that variance covariance matrix, I can use it for multicollinearity.
No. Remember, multicollinearity is only related to what? To the independent. You need the matrix of x prime x. Remember, leadership. To test for multicollinearity, you need the x prime x matrix, not the inverse. We'll get to that one because today's session is about some of the proofs and that multicollinearity part. So we're still going to touch on that on the second period. This first period, I just want to address everything that was asked via email. Leadership was asked me a question. I didn't see. The question was for yesterday. Can I ask now? Yes, you can ask. Of course, ask your question is fine.
Sir,
Yes.
my question is based on chapter 5.
Chapter 5, yes.
There was a question whereby we had to use backward elimination to remove variables, but on the table there were no p-values. And another thing is that on the book it says that if given t-values, the one with a t-value closer to 0 is removed first. So does that
Yes.
mean that when we have like t-values, we use this statement?
You are referring to which question, madam? The quiz question.
No, it's on it's a previous question paper. I just don't remember which one it is.
It's fine. You can send me the question paper, and then we can discuss in the afternoon. Just look for the question paper, or if you happen to find it when we're busy in the next period, you can share it with me. It's my question paper.
Yes.
Yeah, it's fine. Send me the question paper, or the part that you are referring to, and then I will
Okay.
I will I will I will help you, leadership.
Okay. Thank you.
Let's go to Pritinkanyane. Pritinkanyane is saying, sir, I have calculated SSR the way we are doing it on simple negation. Sir, if I calculate SSR the way we were doing on simple negation, will I be wrong? No, I cannot see a screenshot, leadership. But if yeah, it's fine. If I understand what she's saying. Remember, I said for you to find SSR of x1, you can simply say, or this one maybe let me project. You can simply say beta 1. How do you find SSR? SSR of SSR of x1 is the same as beta 1 at SSXY, isn't it? Am I right? How do we find uh, the beta? SSR of x1, is it not the same as beta 1 had SSXY? Can someone help me? Yes, so it's the same thing, leadership. I just changed the beta. That is why now I said it's SSX1Y squared. You just change. If you change that beta, you'll get back to you will get the same answers. It's fine, leadership, as long as you are talking about partial F test. But if it's multiple linear regression, you cannot use that. You have to use the matrix notation. I hope I have answered your question, leadership. If not, you can make a follow-up. It seems like I'm done with the questions. Oh, this one I'm done. Those are the only questions that I received, guys. Did I miss a question? Maybe that you sent me last week or yesterday during my holiday. If you send me a question, please guide me. Where can I find the what? Because I want to move now. So yes, I'll be here. Remember, we're having a class to iron out everything. After that, it will be 2:30. I can be here until 4. I can help you. I can be here until 4. So if you want to consult, you can consult. Okay. She said she sent the question. Let me check the question. Which one, leadership? Let me check. Yeah, so share these question papers with others, but don't memorize, because I'm not a fan of repeating questions. So, but to check how questions are being asked is very, very important. Questions C and D are based on backward elimination method application. Which variable will be removed first? Justify your answer. Which variable will be removed first? Which method was used here? Oh, but leadership. Bukosi? Bukosi?
Sir.
What is happening is that when we use statistical softwares, they bring questions in different formats. For example, can you see the first column where it's written B?
Yes.
B, you see B. It represents the betas. But when we move to SAS, let me show you the SAS one. But when you move to SAS, you'll get a different thing. Let me check. Can you see the SAS output?
Yes.
Yeah, I want to show you something. You remember that one that I showed you? It says what? B, isn't it? But when you use SAS, it says what?
Parameter estimate.
Parameter estimate. Now, when you use SAS, when you want to find the p-values, it says what? PR greater than absolute values of t, isn't it?
Yes.
These are the p-values. But when we move to SPSS, it uses what? This column next to collinearity, can you see it? Where's written
Yes.
sig? Those are the p-values. So SPSS, the way they will be given the p-values, it will be in that format. Sig, those are the p-values. Those values under sig, those are the p-values. So you can use that column to say which variable will be removed first.
Okay.
So tell me which variable will be removed first, leadership?
No, can you go up?
Yes.
X3. Wait, not X3, X7.
X7, isn't it? It's correct. It's X7. So that's how you remove. And then I can even move to, after you find your findings in part C, check the question, leadership. After your findings at C, after removing that X7, is it possible to remove another variable from the same results? Can you please justify your answer, leadership? After finding your findings in part C, is it possible to remove another variable from the same results? Because this question is repeating itself.
Yes.
Why?
Sir, under backward elimination method, we repeat the process until all the independent variables that are not significant are removed.
Thank you. Let's read the question. The issue now is, did you understand the question that we are answering? After your findings, after removing X7, is it possible to remove another variable from the same result?
No.
No, but you remember you said yes at first. So
No.
that's what I also noticed from. That's what I also noticed from your quizzes, the quiz that you wrote. When you read the question, you didn't read it for understanding. You guys, you read the question for answering. Because we said yes. The very same question was there in the quiz. You guys were saying yes, yes,
Sir,
yes, yes.
is it gonna be X7 or X?
To be removed first. The variable to be removed first, leadership.
Oh, I was looking at the wrong column.
You are looking at the tolerance column. Ne? Which column were you using? One?
Oh, I didn't see that at the top.
Oh, sorry. You focus on the sig, but as I've indicated, we are going to go to these out softwares and explain how the layout and all those things, so that you don't get confused. So what else? So now I want to move. I suggest today we should not have a break, so that I help you guys. Anyone who sent me an email that I didn't address, because I don't see another email here which was directed to me related to consultations. Or if you have follow-up questions, guys, please ask before I move. Can I please get 2 or 3 questions? Any question that you or any challenge that you encounter when preparing for the test, or for the test? Any question, challenge that you faced? Ask, guys.
Sir,
Otherwise, I'm moving.
sir,
Yes.
can you please repeat the interpretation of categorical variables, multiple categorical variables?
Categorical variables, like when you have how many options from that variable?
4.
4. Okay. So what do you do first? You have 4 options. What do you do first, leadership? That's fine. Let me connect there so that I can move to what? I can move to the whiteboard. The issue is not to rush to finish the syllabus. You must understand that thing. What is important is for you to understand before we move forward. As I've indicated, I said now I have to deal with what? The proofs and multicollinearity. But if there's something that you don't understand, we cannot rush to go and solve those things. We have to make sure that you understand before we move forward. So allow me to share the screen so that I can answer the leader here. Let me know if you are able to see the whiteboard. When you see the whiteboard, please let me know.
Yes.
Yes, okay. So I want to write what you just said, leadership, and then if I didn't capture your information correctly, please let me know. You are saying you are having y, x1, maybe this is age. Can you please give me that variable which is having 4 options? Just give me an example.
It was rural, suburb, and
Rural, suburb,
township,
township,
and squatter camp.
Squatter camp. Yes. So this is x2, or you call it what? This is what is the location, isn't it? What is the first thing that we have to ask yourself? What is the rule? What is the rule of the dummy variables? That is the first question that we have to ask yourself. 1, you must have a what? A reference variable or category or variable. So variable. So what you do, leadership, first, you have to say, let's use. You must first define the variables, isn't it? Let's use squatter camp. Squatter camp as what? as reference variable. So now, whatever you're going to assign, you won't include what? You won't include this option. So now we'll have y, age, which is x1. I'm coming to our question leadership. So now you have rural. Rural now it will be on its own. So you'll have now this one will be called x2, which goes with rural, x3, which goes with suburb, x4, which goes with township. Now, in simple terms, what are we saying? We're simply saying report whenever is quarter camp, whenever is rural, 1 if rural, 0 otherwise. Isn't it? X3, 1 if suburb, 0 otherwise. You move to what? The last one, X4, 1 if township, 0 otherwise. Now you'll have what? Your what? Your problem started with what? Only 2 variables, x1, x2. But it ended up with how many variables? 1, 2, 3, 4. So now the question from the leader is saying, how do we interpret maybe a value, a beta here, beta 2 maybe, which is 1.2. How do I interpret this beta related to rural? Remember, look, rural is what? It's categorical. It's categorical. So whenever you want, assuming that it's related to that one of buying a house, you will say that, assuming what our figures are in thousands of dollars of rent, the price. So you will say, holding constant the effect of age. Remember, you cannot say holding constant the effect of age, suburb, township. No. Whenever you interpret, you come back to these two. Now you want to interpret what? Rural. But these other values, these other options, they are part of what? These other options, they are part of location. So whenever you want to interpret rural, you cannot hold constant these other ones. The only variable that you can hold constant is what? Is age, because it's not what? It's not from a family of location, isn't it? That is not related to this location. So you will say, holding constant the effect of age, holding constant the effect of age, when the house that you want to buy is located in a rural area, is expected to cost this much compared to what? Compared to a house from what? From a squatter camp. Let me repeat. When you want to hold a variable constant, because these other 2 independent variables, they're from the same family with what? With rural. Whenever you keep a variable constant, you only keep the one which is not related to that variable, which is what? Which is age. So you say holding constant the effect of the age of the house. If the house that you want to buy is from a rural area, it will cost this much compared to a house from what? From a squatter camp. Do you understand, leadership? I don't know what's asking the question.
Yes, sir.
Can I now? I want you to now to interpret this one. Interpret B3 leadership 2.7. Interpret this B3. I just want to check if you follow.
Holding the effect of age constant.
Yes.
We expect the house that's located in the suburb to cost 2.7 thousand more than a house in the squatter camp.
Thank you very much. Thank you very much, leadership. Now, can I please go back to age? Assuming that the age is, the beta for age is 3. How will you interpret how will you interpret beta 1? Beta 1?
Holding the effect of location constant.
Thank you very much. Holding the effect of location. You know that you say by saying holding the effect of location, you covered all the options. You cannot say holding the effect of x2, x3, x4. No. Remember, these ones are from one family. You can simply use what? The overall term as what? Location. Yes, can you continue, leadership?
Holding the effect of location constant, we
Yes.
expect the house to cost 3,000 every time the age increases by 1.
Increased by 1 year, isn't it? Age is in thousand. It's in years. When you add a year on the price of that house, you expect, holding constant the effect of the location, you expect the price of the house to increase by what? By if by 3,000. Or if it was negative, you expect the more the house becomes older, the more the price goes down. But that one is not always the case. We have houses maybe in can give an example in Cape Town. Those houses, because they were built around during the 1800s, you find that to buy that house is more expensive because of the history related to what? To that house. So, but in a normal case, whenever the house becomes older, we expect the price to go down. Same applies to the cars. My car now, I think it doesn't cost uh, much compared to the time I bought the car, isn't it? Obviously, now if I'm looking for the same car with the same kilos, now I assume my car is cheaper compared to what the time I bought it. So, can we continue? Or anyone who's having a follow-up question for this one? Anyone who wants a follow-up question? That was a good question, leadership. That was a good question. So now, based on this, you can also find what? If you are asked to find the matrix of X, which information will you use? If you are asked to find matrix of X, which information will you use? Will you use this information? Let me circle the information. Will you use this information to find the matrix of X? Let's say information 1, or you'll use information 2. Which information will you use to find matrix of X now?
2.
2. Do you agree, guys? He's saying 2. Do you agree? So it seems like we are thinking.
Why?
Sorry?
Can he explain why too?
Okay. Yes, leadership. They want you to elaborate.
Oh, because x2, x3, and x4, if the row, one of the rows, they are all zeros, it means the house is located in the squatter camp.
Thank you very much. So if you are asked to find matrix of X, you have to use what? You have to use this information, the second information, because you will need to define what? Age. Remember, you'll have age, X1, no, X2, X3, X4. So you'll bring those zeros here. Did you understand? And so forth. And the age 28, 12, and so forth. So the matrix of X now will be
Yeah.
represented based on what? Yes?
My network has been cutting. Can you come again?
I'm saying the it's fine. Let me clear this one because now the board now is because now remember we have x2, x3, and x4 and age. Matrix of x now should be related to what? To these new variables. But if you used what? Where there's age and location, you will say what? We will say x equal to what? This one is fine. But when coming to the location, how will you represent your location? So this is not possible. You have to move to a case where you define them. So you have 28, 12. I'm just giving an example here. So wherever you see a location is, whenever a location is from what? What was the first option there? The first look, x2 goes with what? X2
Suburb.
goes with what? Suburb. Remember, we said 1 if suburb, 0 otherwise. 1 if the second one was what? What was x3?
I think
Oh, it
township.
was rural.
Rural.
Rural. The last
Township.
one, township. So you'll say 1. So now when you are ever asked to find matrix of x, wherever you see suburb, you'll put 1. Otherwise, it's what? Is zeros. Wherever you see rural, you'll put 1. Otherwise, it's what? Wherever you say suburb is 0. So the new matrix of x will be this one, not this one, not where you didn't define what. How will you capture location? Because we don't want to say suburb, rural here. So the correct matrix will be this one. And then you write here. Yes.
So also gonna add the size as well again
The what?
on that matrix, the new matrix, because I can only see age of the
Oh, he gave an
other
example of age.
things.
He only I gave an example of age. Yeah, if you want to relate it with the class example, you also add what? So it means this one will be x3, x4, x5 there. If you want me to bring the size here. And the size is 2, 4, 3, and 12. You are right, leadership. So I was just explaining in general, but as long as anything that has to do with X values, they must be represented. So the only part that you have to be careful is to capture the what? That
Okay.
categorical information. Can we move? Can we move? So,
Yes.
I gave you some, I will cover the multicollinearity part, it means in the afternoon, because looking at the time now, what time is it? Can someone help me with the time? Because I cannot see when I
20
projected the
past
white.
8.
20 past
Okay. So let's do some proofs now. We'll do the multicollinearity part.
20.
I want to help you guys. I gave you some proofs to do. No one is consulting about the proofs. And I said, from the upcoming test, you will have proofs in matrix notation, unless if you are fine with them, because no one is asking about those proofs if whatever they've done is correct or not. But I will help you to solve some of the proofs. There is a part which says E is equal to, what was the proof? Check from your notes. E is equal to
E is equals to
1 minus h.
1 minus
minus
h.
h.
is identity matrix minus H what? Y, isn't it?
Yes.
Yes. So let me help you to just so that you can have an idea on what is happening. You know the model of Y is given by this, isn't it? The model is X. These are matrices, isn't it? And then what? Errors. And you know from simple linear regression, how do you define the errors? It's yi minus yi hat, isn't it? Am I wrong?
Right.
Leaders?
You are
Yes.
right.
So in matrix notation, in matrix notation, it's the same. E is equal to y minus y what? This in matrix notation is the same thing. So this one is since simple linear regression also it applies in what? In multiple linear regression. But in multiple linear regression, usually we use what? Matrix notation. So if y is given by this one, so what will be y hat? Y hat is given by what? X B what? Is this thing information is there in your study guide. What happened to E? What happened to E? Why am I not writing E here on the next part? Why are we not having E here? Why?
The
Because the
estimation
expected
of R is 0.
is zero, isn't it? Can you prove this? Can you prove this? But now the issue is not that one. So now let's do this one. Let's prove this. Let's prove that E is given by that. So what you will do, guys, you will say E. You start from this part here. You start from here. Y minus y hat. You know what? You know the what? This part, isn't it? You know it, isn't it? That y hat is given by what? Xb. So y minus xb hat. And you know, beta hat, you have been using the formula for beta hat as what? So you can replace it there. And you say what? Y minus x beta
Sir,
now. Yes.
what if from the first step I continue and say y minus expected value of y?
Y minus
Expected value.
yeah, I'll come to that one. What matters? There are a lot of methods that can be used to reach the final answer. Most of the steps, I don't think if you did the right thing, you will get it wrong. So why? I'm coming to that one, leadership. Why? And then in matrix notation, we have this part. This part here. Oh, I want a different color. This part here is called a head matrix. It's called a head matrix. Represented by what? Represented by H. So I will explain the theory about the head matrix. Remember, I'm saying X inverse multiplied by X prime. This is a head matrix. So now let's replace it there. Y minus H is equal to what? Y. Take out the common factor because this is a matrix. We're talking about matrix here. When you talk about the common factor of Y, you'll be left with what? Identity matrix minus H, Y. Do you see it? Is it difficult, guys? Guys, is it difficult?
No. No.
Now let's move to this proof now. Let's prove this now. Because we know that E is equal to what? E is equal, the expected value of E is equal to 0. Let's prove it. Let's prove it. Now I can erase this. Let's prove these things, guys. So as long as you know these properties, you won't have a problem. let's prove it. Expected value of E is equal to what? Let's check it. E is equal to what? Y minus Y hat, isn't it? This is the easiest. Now, you can say the expected value of Y minus the expected value of Y hat. What is the expected value of Y? The expected value of Y, this formula, you can also write it as what? Expected value of Y, value of Y is equal to, check my notes, you'll see this part there. So the expected value of Y hat, so it means I can erase this. So check the notes that I gave you guys. This information is there, but now I'm scared. It seems like you guys, your focus is on the application part only. So this is equal to, the first part is XB minus the one with a head is what? Expected value of XB at, you know this part, guys, you know this. I just changed, where is it? Where is that formula? Yeah, it is. I just changed Y head and changed it to XB. So XB minus X, the expected value of B head. I proved this, I think last week, which means you are left with the expected value of beta hat is equal to what? It's equal to beta 0. Goes back to what you have done with Mr. Chabalala when he was saying, prove that, when Mr. Chabalala was saying, prove that from simple linear regression, Mr. Chabalala asked you to prove that the expected value of beta hat is equal to, I think it was beta 1 here, isn't it? This is the same idea that I'm bringing now. That is why I was able to replace expected value of B, beta hat, beta with B. That is why I changed this to what? I changed this to B. Any question? So solve these problems, guys. Can you see they're not difficult? They're not difficult, guys. So now, yes.
Can you please show the one of summation of Y
I'm
plus
coming to
Y
that
two?
one, leadership. I'm coming to that one. I just want you, because what I want from you guys is to, you guys solve these things and then check if you follow, because it doesn't mean that because I'm showing you how to find these ones, these are the only proofs that I can give you. There are a lot of proofs that I can ask you, because it doesn't mean that was because we are solving these ones, these are the only proofs that I can ask you. No, as long as you have an idea on how to do these things, it means you must be able to solve whatever. So now, before we can go to the leadership's question, sorry if I'm rushing now. Let me go back to that head matrix. Let me go back to that head matrix, which is represented by H. The matrix is symmetric. Which means, is symmetric, which means H is the same as H trans, sorry. Oh, come on, I want to delete this. We're begging you to come and collect your script immediately when we release the email. Why am I saying this? If you are having X, if we're having X matrix, which is given by 2, 4, 4, 6, what is X transpose? What is the transpose of this matrix?
2, 4, 4, 6.
2, 4. It's the same thing, isn't it? It's the same thing. So we can replace h prime by h. Now with that knowledge, now let me move to another proof now. So and again, h is idempotent. H is idempotent, which means when you multiply the matrix of H with H, you will always get H. That is the meaning of idempotent. When you multiply the matrix of H with itself, you will get H. Let's prove it. H, we said H from the previous step. H is equal to X, the inverse, X prime. So now H is given by this. So we are saying if you multiply H with itself, you will get H. Even if you multiply H by H by H, you'll still get what? You'll still get H. Even if it's H by H by H, it's equal to H. Let's prove it, guys. If you don't understand, make sure that you stop me and then I will explain. I need the space. The reason why I'm not removing the part on the right side, we'll need that part when solving the next proof. But I'm begging you guys, please go and solve all those proofs so that we get used to it. Because you cannot lose, even if you don't know the proof, but losing all the marks is not good. H by H is equal to H. Let's prove it. We're saying H is idempotent because when you multiply H with itself, you get H. So the first H is given by what? X inverse X prime. And the next one is X. You can put brackets if you want. Inverse X prime. Oh, there's an equal sign there. Now, let me put another bracket here. But if you check the middle two, these two, we can combine them. So we'll be left with X inverse of X. And I want to combine these two. X prime X. I want to put this inside what? Inside the bracket. And we're left with X inverse. Oh, sorry, let me use a different color here. Let me use a different color. X inverse. So checking at these two, now let's focus at this part now. Let's focus at this part. This part is equal to what, guys? That part is equal to what? That part is equal to what?
I.
Identity, isn't it? Thank you, leadership. So we know that we'll have what? X inverse. Leadership is saying the black part is equal to I, and we're left with what? Sorry. Not only the black part. The part that let me do like this. We're saying this is equal to X. The part that I highlighted, you're saying it's equal to I. So go through these things, guys. You are in a situation, so you have to take yourself out of that situation. You know the situation that I'm talking about. This is the same as, it's not a must for you to write an identity matrix because you are just multiplying, which is equal to what? Which is equal to h. So I have indicated that h is the same as h prime. The next proof will need what? Will need this rule. So the next proof. So guys, when you are relaxing, just go through these proofs. When you are ever relaxing, go through these proofs. Now I want to solve last two. From there, the other ones is your responsibility. Let's find, because we know that, let's solve the variance of error. Let's solve the variance of error, guys. You know that variance of error is given by y minus y. This is the same as, so this one, guys, immediately when you are given this type of problem, these are just giveaway marks. But this one, there's no need for us to waste time because we'll know that the final thing will be what? The final thing will be identity matrix. Oh, I need another bracket here. Identity matrix minus h, y. And what is the variance? The variance of ax given that a is a constant. This is the same as what? This does not have to do with the question. This is the properties of the variance. This is something else. Suppose you are asked to find what is the variance of x. Can you please expand this? Given that a is a constant. This is the same as what? Yes?
A var x.
A var x. I think there's something missing.
A transpose.
No, not in matrix
A squared.
notation.
A
A
squared.
squared. Thank you. So the very same thing in matrix notation, variance of ax provided a is a constant. This is the same as a variance of x a prime. That rule will need it here. That rule will need it here. So you see, these things are connected. Now let's move, guys. Where am I? Okay. So now let's apply the rule. Let's apply the rule. Remember, we can take out this one. So it means we'll have I minus h variance of y, I minus h transpose. I explained the rule now. And then this one is the same as I minus h. The variance of y, you know that the variance of y is what? Sigma squared multiplied by identity matrix. But usually, even if you didn't get the identity matrix, it's fine. But because we're dealing with matrix notation, you can indicate it. So this is variance of y. You know this one even from Mr. Chabalala's section. H minus, sorry, identity minus h prime. Now we can take the sigma squared out. We'll be left with I we'll be left with I minus h, the bracket here, multiplied by I minus h. Now I can remove this part because it was related to this part here. Now let's go, guys. Let's move. This is equal to sigma squared. Let's multiply the two, guys. Let's multiply. Remember I said H transpose is the same as H. Same applies to when you transpose the identity matrix, you'll get the identity matrix, isn't it? So this is the same as when writing this information in this format. That transpose can disappear. It's not a must, because when you transpose the matrix of H, you'll get H. When you transpose the matrix of identity, you'll get an identity. So identity multiplied by identity is identity minus identity H minus identity H. H by H is equal to what, guys? H by H is equal to what?
It's equals to H.
Equals to H.
Let me write it, it's fine. So it's sigma squared I, combine the two, minus 2H plus H, isn't it? So the final answer is sigma squared I minus H. Are we not having this proof from that out from the given options that we need to solve? Guys, talk to me, guys, talk to me. Are we not having this proof?
We do.
Yes. Now, can someone help me now? Let's solve this one. Who want to work with me? Who want to work with me? I'll be listening. I'll be listening. Who want to work with me? Anyone want to work with me? Guys, you see now you've started. Let's work.
Say, let's work.
Okay, who's talking?
Mangani, of course.
I'll be listening. Let's go.
We know that we can replace y head by x beta head.
Thank you. X beta.
So the way I did it, I took out the x outside.
Okay. I will advise you not to do that to avoid to complicate the question. I will advise you to change beta head.
Yeah, so
Don't take it out now,
okay, it will be
because if you take this one out, why not the two? Because if you take them out, the two must go. Remember, your focus is to have y, isn't it? As
yeah.
part of your yes x.
So we have x. Then I change the beta head into
I'll
x
change it for
transpose.
you.
Yeah.
Yes.
Then we take the variance of y.
Remember the head matrix notation. Can you do that? The head matrix
Yeah.
notation. Don't you see h from your statement? Change it.
Yes. That the
The
first part there it will be h.
h y, isn't it? See,
Yeah.
now you symbolized it. You see, now we have symbolized it.
Then
Let's go.
the variance of it will be
So this
h
is the
the
same as
variance
what?
h the
H, the
variance
variance.
of y.
Are you
Then the
done,
variance
leadership?
huh? Then h
Leadership. Remember the
h
rule.
H transpose.
No, I cannot write what you didn't tell me. I only write what you are telling me, leadership.
Oh, yeah.
Yes,
Then
let's
from
go.
there, that the variance of H, you write H.
H.
H, the variance of Y is sigma squared identity. We can also write sigma squared.
Okay.
Yeah. Then H transpose, of which we can also change the H transpose to be H.
Thank you.
Then
Let's change H. H is equal to what? Let's
H
take it back.
X into, yeah, that.
So this is the same as sigma squared X. Isn't it?
Yes.
I think there's another one that we can prove from that note. It was variance of what? Check from my notes, the recent notes. I think it goes with part 3. There's a part that I added there.
It was variance of beta heads.
Okay, let's go to that one. Because these things, guys, variance of, let's go. Now, can I please get a different person? That's why when I joined you guys, I said you must feel jealous if you must be jealous if you didn't talk to me by the end of this class. Variance of you said beta like this.
Yes.
Let's go. Let's go.
I did.
Can I get a different person? A guy, please. Preferably a guy. Oh, it's fine. A woman. A woman.
We're going to
A
have
woman.
Try to
variance
change
of
beta heads to
I change it. Should I change? You want me to change beta head?
yes.
yes.
Yes, I have done that. I have done that. Let's go.
And then you take the variance of that, the var of X. Let's just Lisa, can we please name this to be A, the beta head, which is X prime X inverse, and then X prime
This
to
part.
be A. Yes.
You want me to let?
Yeah, you can let it A first.
Okay.
And then we'll
Achieve.
have
Okay.
and then we'll have the A. You have A var
Yes.
of Y,
Var of y.
and then you say A prime.
A prime.
And then from
Yes,
there, you
leadership.
know the var of Y is sigma squared. You just say A.
Sigma squared identity.
I,
A
A prime.
transpose. It
And
means
then
from here it's not a big issue, isn't it? That
yes,
means now you can bring back what? You can bring back your A.
you're late. Yes.
Yeah. So now you say thank you, leadership. X transpose X.
Enjoy.
X. Thank you. Thank you, leadership. So you know this is your first part. Your second part, these properties. Remember my properties? I gave you some properties last. So here you are going to have what? Inverse. I think we'll need 2 brackets because we have a transpose there. Multiply by transpose. This is what we have. The variance of betas is this one, guys. When you want to find them, what is the a notation for the covariance covariance matrix? What is the notation? The first part, you say that part equal to what? Before you say MSE multiplied by the inverse. Can you please check from your study guide what is written here? Just check it from your notes or from your study guide. What is there? It's variance of what? When we represent the variance covariance matrix, is variance of what?
Covariance of X transpose X.
No, I mean the left side, it says variance of what? In symbol notation. B.
So doesn't it say variance of E?
Variance of what? Variance of what, leadership?
It says variance of B.
Variance of B.
Variance of. So if you are talking about the estimate, it will be variance of what? It will be variance of B, isn't it? So you know that your final answer that you must get here, it will be what? Sigma squared. If it's estimates, you put a head there, isn't it? X prime X. So that's what you're also expecting here, because you're not talking about the estimate. You'll have what? You'll have sigma squared X prime. This will be what? This will be your final answer from this step. So you go and try it.
So
you see, guys,
can you
see these
finish?
are not difficult. Yes, leadership. I cannot see. You see your hand from my position if I projected the whiteboard.
Sir,
Yes. Yes.
So can you
regarding
please
this,
finish this thing?
Sorry?
sir,
Second,
Yes. Can I get the guy first and then leadership will follow?
regarding this, the variance, you use sigma squared head. Am I allowed to use S?
Yes, you're allowed. You're allowed leadership. It's the same thing.
Okay, thank you.
Thank you very much. So this part here, if you are reading
so
my
can I
notes,
finish the part?
what done leadership? We solved it for you. Yeah, it is.
So I just want to explain how did it go from
Okay,
there.
it's fine. It's fine. Yeah, I'm listening, leadership.
Okay, so that one that you put area green here,
Yes.
so yeah, you
Yes.
change that one here transpose to be X,
Yes, you are right.
and then
This
it will
one,
cancel with the other one.
this one. Let me use a different color. Thank you, leadership. I
Yes.
like giving. I like giving tasks. Ne? So this
I
part here, this one, it will change to what? It will change to X. And this, remember, we have this one here. When you mix the two, you'll have X prime X. When you mix, you take this X prime, and this part now will cancel with this one. The remaining part will be what? Will be this part. That is why it is. That is why it is here. But it's fine, guys. I'm happy because you can follow. So this proves when you see them from the what do you call, from that they look scary now as well. But if you solve them, you will enjoy. But what we need to know is to know what the properties. And again, there was someone who was here last after writing Mr. Chabala's test. People are complaining that we have a lot of formulas. But what can we do, guys? So you cannot say, hey, I failed because I forgot that formula. But what about the other things that you wrote which didn't need that formula? Did you pass them? No. So I'm begging you guys, we'll send an email. We just have to want to capture the marks first. We're almost done marking, except Guys, as far as we want to help you, whenever we solve, we ask you to save the documents using what do you call this thing? Why am I forgetting this? Using PDF. Please do so, because now some of the things that you send, guys, those who submitted pictures were failing to print them. Some of them were even failing to open them. You submitted what? You submitted a picture. Now what I've done, I only marked those who were submitted using PDF format. But if you submitted a picture, it's difficult now to print that picture. So please, guys, if you don't know how to save your work as a PDF in a PDF format, ask other leaders. Swallow your pride, guys. Ask the other leader. They won't judge you because, say, you are doing final year, you don't know how to save your work PDF. No, no, no. Ask someone who can keep a secret. There will be that someone, guys, that can keep a secret, like myself. You can keep a secret. If you don't know, ask me. If I say out your secret by mistake, it will be a mistake. Now, if I tell someone, it will be a mistake. It won't be intentional. So please, guys, if you don't know how to do something, because now, if we fail to open your script and your script is not saved in the right format, so you don't have a case. We have to give you a 0. You cannot say, yes, the work. You cannot say, yes, my work. No, 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 no. You failed to follow a simple rule. So what do? We just have to write a 0. You cannot say, no, yes, my script, let me resubmit. No, 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 no. It doesn't work like that. So please, guys, it's better if your document is not opening by saved in the right format. That one is better. It's technical problems. But if you fail to follow a simple rule, it becomes a problem. And I know some of you, you will you want to argue. For example, if I ask you to write my surname, you start with a small letter, and I tell you what you wrote there is wrong, and you want to argue that no, I'm right. I'm telling you, you cannot write my surname, the first letter being what? A small letter. My surname is a must that the first letter should be what? A capital letter. So you cannot argue that no, but what I wrote there is Malulek. What is the first letter? Is it a capital letter? No. So it means that one is not Malulek. You see it? So please, guys, let's do the right things. Any question? I will do. Please attend the afternoon session, because that's where I will be ironing out what the multicollinearity part and the theory. Some of the theory, this new theory, we'll see it in the afternoon. Remember your test. This one maybe I want to be on record. Your test, 50% application, 50% theory plus proofs. This is what I wrote from Blackboard, isn't it? This is what I wrote from Blackboard. 50% application, 50% proofs. So question one is 30 marks. Question 2 is 30 marks. Which is total 62 hours. Rule number 1, start with the question that you understand better. That's my rule. Start with the question that you understand better. There's no rule that you have to start with question 1. If you think question 2 is you understand better than question 1, start with question 2. But the numbering must be clear, guys. You cannot say question 2 E. After writing E, you go to A. No, 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 no. If you start with question 2, order matters. If you start with question 1, order matters. If you don't know a question, you just say A, you skip it, you will come back for it. Any question, guys? Talk to me. Talk to me. Yes.
Can you please do the one that has a summation of y square? The proof.
I want you to try it and then I will come in. It says what?
It says a summation of y square.
You mind to do it like what leadership did?
B here prime.
I want to go out of this. I want to give you a hint. I want to check if I follow. Where it is? Oh, thank you. It says what?
Summation of y I square equals to B head prime x prime y.
No, I corrected this, isn't it? I said supposed to be a head here. I didn't correct it from my previous my chapter 3 part 3. Is it not having a head?
It is.
It is having a head, leadership. Whenever you solve it, bring in the head. Try it with a head. Without a head, it's not possible. Try it with a head. Yeah, please. Try it. Afternoon, you give me the answer. I correct you. Because now, another thing that I want to emphasize, when we're doing these things together, they look easy. They look easy, guys, when we're doing these things together. But when you're alone, please make sure that you practice. Because you may find that we did something here, it looked so easy. But if I can ask you to solve it again, you may have problems. Check the proof that we managed to cover. I think we managed to do 4 or 5 proofs within a short space of time because we're doing it what? Together. So I don't think that we still have a lot of time for what? For advice. What you have to do, guys, is you have to go back to the drawing board, check if you have covered all the sections. Don't ignore theory, guys. Theory is not like I'll be asking, I'm just trying to give an idea. What is regression? What is coefficient of determination? No. Those ones are not of your standard, guys. Theory is you'll be given a scenario where you have to think, like what we have been doing at the quizzes. Remember the quizzes? I'll give you a statement, and then based on that statement, I give you questions, like follow-up questions. Remember the way I gave you question 2. Question 2 is theory, isn't it? By knowing which variable to be removed first, interpreting why it was removed first, explaining how the variable was entered, that's theory. The theory that is there is something that you know, provided you have done your part. Yes, leadership.
So by that, do you mean that there won't be any definitions?
I didn't say that. Definitions, like you want me to ask you what is backward elimination method?
That's what I'm asking. So are those the kind of questions
No,
you're going to?
this is just also a follow-up question. Like example, what is backward elimination method?
That's also fine, sir, if you're asking it.
No, it's better to ask how will you apply backward elimination method?
All right, thank
I think
you,
this
sir.
one now it needs the procedures that need to be followed to run backward. Let me give you an example, leadership. What is a residual? What is residual analysis? Isn't it, leadership? What is residual analysis? You have done this part with Mr. Chavalala. It's where you want what? You want to assess the model, isn't it? Am I wrong,
Yes, sir.
leadership?
No, you're
Residual
not.
analysis, you want to assess the model, I guess.
Yes.
So let me twist the question. What is the use of residual plot? You see, instead of asking you residual analysis is to what? It's a method to access the model. Now I say what? What is the use of residual plots? Why do we have to check the residual plots? The answer is the same, isn't it? We want to
Yeah.
assess if the model is good or not. But it was not direct.
All right.
But the answer is the same. It's the same as what is residual analysis. Instead of saying what is the residual analysis, I ask you what is the use for what? For the residual plot. Do you get that,
All
leadership?
right.
So we need
Yeah.
someone who understands what is happening. Memorizing, guys, it's like if I can ask you, uh, what is the what? How do you find the mean? How do you find the mean, leadership? The mean, like, let me write it here. Suppose you are given a data, um, x. Where's that pen? X 92476.
Yeah. Sum divided by n.
Sum divided by n. Can
Yes.
someone? How do you find the mean? He said sum divided by n. How do you find the mean? Can someone give me an? Yeah, you are right. Can someone give me the answer? How do we find the mean? He said sum divided by n. Anyone who can explain it in a different way?
Sum of x.
Sum of x divide and then you're not done, leadership.
Sum of x divided by n.
Sum of x divided by n. Someone can say summation of the given observations divide by what? Divide by the sample size, isn't it? All the answers are what? Are correct. So what I'm trying to say here, there's no need for you to memorize the definition from the book. What we need is to check if you understand what we are talking about. Like now, what is multicollinearity? Why do we have to test for multicollinearity? Do you understand, guys? You cannot say, no, I cannot write this one. I forgot the definition. I didn't see the definition from the study guide. Why do we have to do multicollinearity? Use your own words. Why are we supposed to use those VIF methods? Why? You understand, guys? Even if you didn't see the what, you didn't see the definition from the study guide, but you know that for you to check for multicollinearity, what is involved? Only independent variables are what? Independent variables are involved. And you find what? X1, correlation of X1 and X2. Now, reason from here. Multicollinearity is where we check what? The relationship between the independent variables. What is the reason for you to do that? To check if these two variables are not what? Are not correlated. You see, because you know what? R is for what? Is to check for the correlation. You didn't see the definition from the study guide, but you remember that like I said, we have three methods to do what? To do that. But how do we get to the VIF? 1 divided by 1 minus r squared of x1, x2. How do we get to finding the VIF or the tolerance? We use what? We use the independent variables. So the reason for one to find the correlation coefficient is to check for the relationship. So here you'll be checking what? Multicollinearity is to check for the relationship between the independent variables. So I'm not saying if I ask you a definition, memorize the one from the study guide. Here what we're checking your understanding. I thank you. Enjoy. So for more questions, let's meet in the afternoon. It's a must for you to attend that class. If you don't attend, you are just digging your own grave. And tomorrow, I won't accept any consultations. To me, during the day of the test, no consultations are allowed, as I've indicated from Blackboard. Tomorrow is time to wrap up. It's not time to what? To come here, start asking questions. If you are not going in the right direction, you will even stress me. So please, tomorrow, use that time to finalize whatever. It's 2 o'clock, leadership. It's 2 o'clock. I will share the information on Blackboard. It's 2 o'clock from 2 to 4. I will also share the list, the sitting list on. I will share the sitting list on what on Blackboard, so that. But if you fail to see it, I will also paste one outside the venue where you'll be writing the test. So that one is not supposed to be an issue. But my advice remains, please collect your scripts. This script will help you to check where did you go wrong. Oh, and there's another question. Oh, I don't know if I have answered you, leadership. She was talking about multicollinearity, but I think I have answered. Multicollinearity, you only need the x values, not the inverse. I'm not sure if I have answered that one. So whoever asked the question, please, whenever you check multicollinearity, but since we're still going to cover it in the afternoon, I'll be able to explain in details what I mean by that. So thank you very much, guys. Let's change the situation. Yes, Omu.
Sir, good morning.
Morning, leadership.
So can I ask something based on the multicollinearity, those three formulas? Are they giving us the same answer?
Which three formulas?
The one of 1 over tall, and the one of Rx1, X2, and the other one of 1 minus, I think, is Rx1, X2.
What do you mean they're giving us the same answer?
I mean that if you use the first one and the second one and the third one, will you get the same answer, same value?
Oh, you're not supposed to get the same value, leadership. Leadership.
Oh.
Leadership. If you say leadership, if you say 1 minus R squared, there's no way that it will be the same as 1 minus 1 over R squared, isn't it, leadership?
Yeah.
Because this one is the reciprocal of this one, isn't it? That's why we say VIF is equal to 1 over tolerance. And even when you compare, when you use the tolerance procedure, you check if this is not less than what? 0.1. When we use the VIF method, we check if this is not greater than what? Greater than 10.
10.
For a serious multicollinearity. But if you read my notes about multicollinearity, I also indicated that if the value is not 10 but is greater than 4, I indicated that this is potential multicollinearity. It's there. Read my notes, guys. I gave you a document, I think, with 5 pages. Go through that document. The language that is being used there is the language that you know. Thank you.
Sir, the last one. Sir.
I'm listening.
Okay, that issue of is t squared over f on this chapter. How did you say this point that I did not get it? The one of t squared equals to f.
That one was covered by Mr. Chavala, not me. but
Oh,
it's also there. It is also there for partial F. But that one you should not focus much on it. That one, if you're not careful, it can mislead you. So stick to that one. Is you are safe to apply that procedure provided you are dealing with simple linear regression.
okay. Thank you, sir.
But if this one it needs me to connect again. But leadership, if you want me to explain, let me explain in this way. Uh, let me know if you are able to see the screen. Let me see if you can tell me if you're able to see the screen, the whiteboard.
Yeah. Okay.
Partial F, partial. Now, assuming that we have x1 and x2. So it means when you want to find x1, matrix of x1, it will have how many values? Two values, isn't it? So they have this matrix. Matrix of x2, it will have values like this. Matrix of x2 and x1 will have how many values? 1, 2, 3. It will be like this. The f for these two, t squared is equal to f for this one. T squared is equal to f. But for this one, t squared is not equal to f. Do you understand, leadership? Why am I saying this? Remember, here we are having y and x1. This one is taking you back to what? It's taking you back to simple linear regression. Am I wrong, leadership?
Oh,
You
you're
have y and
correct.
x1. You solve the questions. If you want, you can even use the questions that the formulas that you used with Mr. Chabalan. That's what the leader was saying. Because you can solve the problems the way you used to do it with Mr. Chabalan. Same applies to this one. You have y and what? And x2. So t squared is equal to f. It's true. But now, here you have x2 and x3. x1 and x2. So t squared is not equal to what? Not equal to f. Because now, for the last one, you have y, x1, x2. You follow, Eumu?
Yeah, I follow. So the reason behind that it can be because we have two independent variables.
Yes, that is the reason.
Okay, thank you.
That is the reason. Because the t with you guys, remember when you are dealing with simple linear regression, the t that you get here, you can replace it to what? To under the coefficients, isn't it? The t for x2, the t will be what? The value that you take, when you take the square root here, when you take the square root here, you'll find what? The value of t. But you should also be guided by what? You should also be guided by the sign of what? The sign of your beta. If your beta is positive, it means your t will be what? The t will be positive. So um, this one is something that we have. That's why it's there when we check partial f test. I think there's a part which says t squared equal to f. What we have to check there, check this part, leadership. Next to f, I think there's 1 n minus p. Isn't it, leadership?
Oh yeah.
N minus p or n minus 2. I don't know what is written there. It's only applied when it's like this. But with this one now here we are not having one independent variable. We are having two. Do you understand, Om?
Yeah, I understand, sir.
Yeah, but you can also raise the question in the afternoon so that we can also help the other leaders. Ne?
All right, sir.
Okay, thank you. Let's meet in the afternoon. Enjoy.